Okay, so for numbers 11 through 17, it's asking you to solve and then to put your answer in interval notation and in graph form. So let's start by solving. I'm going to bring this to this side like we always do by adding it. And I'm going to get x is less than or equal to 3 plus 4 is 7. So if you think about what x is less than, you just pop a 7 down on the number line and then put a bracket like this and then draw a line like this. You need to put an arrow on the left side of it. Now, this is pointing toward negative infinity. This over here is positive infinity, but it stops right here. So in interval notation, we just represent what we see here. So it's going to go from negative infinity all the way up to 7 with a bracket. So this is called interval notation, and this right here is the graph form of it. Okay, this is number 13. Oops. All right, so we're going to move the 1 over to the right by subtracting it from each side, and we're going to get 4x is greater than or equal to 20, and then we'll divide by 4 on each side, and we'll get x is greater than or equal to 5. So if you think about the graph is going to look like this. We're going to start at 5. We just put a line arbitrarily on one of these numbers at 5, and then it's greater than or equal to, so we'll put a bracket and point that way. Now remember, if it was just greater than, we'd put a parentheses and go that way, okay? And then, so then when you go to put it in interval notation, you just mimic this. This is pointing to positive infinity. So in interval notation, oops, it's a bracket. We're going from bracket 5 to infinity. That's it. Okay, we're going to get rid of this 5 by dividing it out on each side. And then we're going to get x is greater than. Now, this is a negative 25. That's what's being divided. We're dividing by a positive. So this does not flip directions. So we're still going to have a negative 5 there. Okay? And then if you think about what the graph looks like, because it's a greater than, we'll put a line here. We'll label that 5. We'll put a parentheses instead of a bracket, and we'll put an arrow that way. Okay? And so in interval notation, this is going from 5 to positive infinity. That's it. Okay, here we want to get rid of this negative 4, so we're going to divide by negative 4, and we do that on both sides. And then we're going to end up with x's. Because we're dividing by a negative, this is going to flip around. It's going to become a greater than. 16 divided by negative 4 is negative 4. So when you think about the graph, it's still a greater than. We're going to label an arbitrary point on here as negative 4, and then it's a greater than, so the parentheses is facing this way, and it's going to infinity. So in interval notation, we'll go negative 4, comma, infinity. And that's it. Okay, for number 23, we're going to get rid of our fraction by multiplying each side by the denominator. So we're going to multiply by 4, and we'll have to do that to both sides. And then that's going to cancel, and so we're going to end up with 3k minus 1 is greater than 5 times 4 is 20. So now we're going to move the 1 over to the right by adding it to each side, and we're going to get 3k is greater than 21. And finally, we'll divide by 3 on each side, and we're going to get k is greater than 7. So if you think about what the graph looks like, well, let's just draw a graph here. You put 7 down as an arbitrary line, and this is greater than, so we'll make a parentheses, and it's going this way. And that's it. And so in interval notation, it's from 7 to infinity. And that's it. Okay, number 25. Here's the problem. We have this over negative 4, and we want to get rid of this. We're going to multiply each side by negative 4. Okay, now over here, these negative 4's cancel, and we're left with 2k minus 5. Because we're multiplying by a negative, this inequality is going to flip directions. And 5 times negative 4 is negative 20. And now we'll move the negative 5 over by adding it to each side. And we'll get 2k is less than negative 20 plus 5 is a negative 15, and then we'll divide each side by 2, and we'll get k is less than negative 15 over 2. You don't have to make that a negative 7.5. So to graph this, on the line, we'll put an arbitrary spot, we'll put a negative 15 over 2. And then this is less than, so it's going this way. It's not less than or equal to, it's just less than, so it's a rounded parentheses. If it was less than or equal to, we put a bracket, with corners on it. Okay, and that's it. Okay, for number 27, let's move this 1 over to the right. We're going to do that by subtracting it. We'll subtract it from each side, and we're going to get 3k is less than negative 20, and negative 1 give us negative 21. And then we're going to get rid of this 3 by dividing out the 3 on each side. And we're going to get k is less than negative 21 divided by 3 is negative 7. Now notice there's a negative in this division, but we're not flipping this because we're dividing by a positive 3. It doesn't matter if this number is positive or negative. It matters what you're dividing by. Okay, so now when we graph this, we're going to put an arbitrary hash mark there, and we'll put negative 7. It's less than, so it's pointing this way. And that's it. Okay, for number 33, we're going to get rid of these parentheses by distributing the negative 3. And we're going to end up with negative 3z plus 6, or not plus 6, plus 18. Negative 3 times negative 6 is a positive 18. Is greater than 2z minus 2. Now, so that you don't make a weird mistake when you're graphing, I'm always going to bring the variable part to the left-hand side. So I'm going to move this over here by subtracting 2z from each side. And then I'm going to move this over here by subtracting 18 from each side. And negative 3z minus 2z gives us a negative 5z. And negative 2 minus 18 gives us a negative 20. Oops, and I put in equals here, sorry. That's a greater than. So now I'm going to get rid of the negative 5z by dividing by negative 5. And we're going to get z is less than, because we're dividing by a negative, that inequality flips around. And negative 20 divided by negative 5 is a positive 4. So when we go to graph this, we'll put a hash mark and put an arbitrary 4 here. It's going less than, so we go this way, and that's going like that. Oh, and in interval notation, this is pointing toward negative infinity. So we're going to go from negative infinity all the way up to positive 4 parentheses. That's it. Now back on number 27, I forgot to put this in interval notation. This is pointing at negative infinity, and it's going up to this. So the interval notation goes from negative infinity up to negative 7. On number 25, I forgot to put this in interval notation. This is pointing toward negative infinity, and it's going up to negative 15 halves. So in interval notation, we'd write it as negative infinity up to negative 15 over 2. By the way, infinity always has a parentheses because there's no actual number that's equal to infinity. Okay, for number 45, this is a compound inequality. Really what you have are two inequalities. One is that negative 4 is less than x minus 5, and a separate inequality that says x minus 5 is less than 6. And we just put it into one inequality like this. So we're going to get rid of this 5 by moving it over to each side. So we're going to add it to each section, and we're going to end up with negative 4 plus 5 is a positive 1, less than x, less than 6 plus 5 is 11. And then if you were to graph this, it's really simple. You just pop two hash marks down on here, put 1 on one of them, 11 on the other, and you just do this. You're using soft parentheses rather than brackets because these are less than, not less than or equals to. So now in interval notation, I just write it like this. That's it. Okay, so number 47, I'm going to get rid of this positive 5 by moving it over to each thing by subtracting it. And we're going to do that to each section. Okay. Now, negative 9 and a negative 5 give us a negative 14. This is still less than or equal to k, less than or equal to positive 15, and negative 5 gives us a positive 10. So if you were to graph this, you simply put two little hash marks down, negative 14 on the left and positive 10 on the right. Because the equal sign, these are brackets this time, and it looks like that. So in interval notation, we just put bracket negative 14 comma 10 bracket, and that's it. Okay, for number 49, I'm going to simplify this section before I do anything else. So I'm going to distribute that 2, and I'm going to end up with negative 6 less than or equal to 2z plus 4 less than or equal to 16. Now I'm going to move this 4 to each side by subtracting it away. So I have to do that to each section. Negative 6 and negative 4 give us a negative 10. That's still less than or equal to 2z less than or equal to a positive 16 and negative 4 give us a positive 12. And then I'll get rid of this 2 by dividing it away. So I have to do that to each section. And I'm going to get a negative 5 less than or equal to z less than or equal to 6. So if I were to graph this, I'll put 2 hash marks down, negative 5 on the left and positive 6 on the right, and I'm going to put brackets, let's see, like this and a line in between them. And in interval notation, I just go bracket negative 5, 6, bracket. That's interval notation. Okay, here's number 51. First thing we're going to do is get rid of this 2 by moving it to each side, and I'm going to do that by subtracting 2 from each section. Negative 16 and negative 2 give us a negative 18. We have a 3t in the middle. Negative 10 and negative 2 give us a negative 12. And now I got to get rid of this 3 by dividing it away. So I'll do that to each section. And I'm going to end up with negative 6 less than t less than negative 4. So if I were to graph this, I'll put 2 hash marks down, negative 6 on one of them, negative 4 on the other. These are less thans, not less than or equal to, so they're just parentheses, like that. So in interval notation, I simply write negative 6 comma negative 4, and that's it. Okay, here we're going to get rid of the 5 from the middle by putting it on both sides, so I'm going to subtract it. We'll subtract it from each section. A positive 4 and a negative 5 give us a negative 1. Positive 8 and a negative 5 give us a positive 3. So now I'm going to divide everything by negative 9. And be careful, because we're dividing by a negative, these inequalities are going to flip directions. Okay, so let's do it like this. Okay, so negative 1 divided by negative 9 is a positive 1 over 9, and 3 over negative 9 is a negative 1/3. Now be careful. The inequalities have to go, the numbers, whether you graph them or put them in interval notation, have to go from the smallest to the biggest. These need to be less thans. If you have a compound, you can't go from a bigger one to a smaller one. So I'm just going to flip everything around. Now if I were to graph this, I'd pop 2 hash marks down, and I'd put a negative 1/3 on the first one and a positive 1/9 on the second one. This one's a bracket because of the equal sign, but this is a parentheses because there's no equal sign. And that's it. So in interval notation, I'll put a bracket on the left for negative 1/3, and 1/9 gives us a parentheses. That's interval notation. Okay, for number 55, the first thing I want to do is get rid of this fraction here. So I'm going to multiply by 6. It means I have to multiply each of the sections by positive 6. So I multiply this by 6, this by 6, and this by 6. And over here they cancel. On the left, 6 times negative 1 is a negative 6. We have a 2x minus 5. 5 times 6 is 30. So now I'll move the negative 5 to each side by adding that to each section. Negative 6 plus 5 is a negative 1. 30 plus 5 is a 35. And finally, I'm going to divide everything by 2. So I'll get negative 1/2 So if I were to graph this, I'll put 2 hash marks down. Label the first one as negative 1/2, and the second one is positive 35 over 2. And these are less than or equal to, so they're brackets. And they look like that. So in interval notation, I'll put a bracket, negative 1/2, comma, 35 over 2, bracket. And that's interval notation. And that's it.